Hello friends, welcome. Today we would be continuing our lectures on percentage questions, and the problems that we would be dealing with today are specifically related to percent change. Right? So these kind of questions, what the basic structure is, they are based on a formula, and the quantities input into that formula are changed by a certain percentage, and the problem would then ask you how would the final quantity change. So here is a very typical example. Here there is this cube whose sides are being increased. So they are doubled basically from here to here. So they increase by 200%, and from here to here they have been increased by 300%. Right? So this is the change in side. Right? So I change the side of this cube, and then subsequently the problem would ask me what would be the corresponding percent change in the area, surface area of this cube or volume of the cube. So this is how these kind of problems work. Right? So there is an underlying formula, quantities input into the formula are changed by a certain percentage, and the problem would ask you how would the output quantities from the formula change. Right? So few things have to be clear before we start solving these kind of questions. The first thing, percent change, right, unless the problem specifies it, otherwise there is some trick in the problem, there is some typical language in the problem. In general, percentage change is final minus initial or original divided by initial, right. So we always measure percentage change with respect to original quantity, right. That is the key thing, original quantity with respect to original or the initial quantity. And don't put final quantity here, that would be completely wrong, and lot of students make that mistake. So keep this in mind. Right? So all the problems that we will be solving today, or at least are in some ways, will be dealing with this formula, and then we would be looking at all the shortcuts, right? All kinds of shortcut tricks then can be used to solve such problems. Right? So keep that in mind. The problems themselves are simple. The arithmetic involved is typically not too much, but the key is in all these questions we have to use shortcut tricks. So if you go back to our previous class, we looked at relative quantities, and if the question asks you about relative quantities, for example, this question is dealing entirely with relative quantities. It is not dealing with absolutely what the size of the cube is, what the size of the side of the cube is. It is not telling us that value absolutely. If the problem is dealing with relative quantities, we can assume that quantity to be anything, right. So for example, in this case, what I would do is that I would assume the side of the cube to be 100x. Right? I'll still keep the variable x here, right, because we don't really know what the side of the cube is, but I'll just assume it to be a factor of 100, and whatever rest comes in here in x. So then the side of the cube is multiplied, it is increased by 100%, so it becomes 200x. Right? Now you would ask me, sir, why would you do this? Why would you choose quantity 100x, 200x? These are big numbers. So yes, you are correct. Right? In this particular problem, we don't even have to choose 100x, 200x. We can go even simpler. I can just choose the side of the cube to be x, and this becomes 2x. This x, 2x, 100x, 50x, choose anything that you want. Whatever is convenient for your problem, whatever makes the calculations simple. Right? So side of the cube is doubled. What would be the surface area? Surface of the area of the cube is, there are 6 such faces. Area of each face is x square. So surface area would be 6x square for this one, and it became 2x here. So 6 into 2x square. Here this would be the surface area of this particular cube. So this surface area then changes from x square, 6x square, to 6 into 2x square. Now if you notice, right, in the final percentage change in area, when I calculate it, as soon as I write that, you will notice that all the quantities, this x square, whatever I had assumed here, 100x, 200x, whatever it be, this all would cancel out. Right? So 6 cancels out. Here x square cancels out. It could have been y, it could have been 100x, it could have been whatever. All of this would cancel out, and that's why I am saying it doesn't matter what you had assumed in the beginning. And finally, what we get is, of course, this is percentage change, so we have to multiply it by 100. If you simplify it, this would be 2 to the, this is square, so 2 to the 4 minus 1, so the area would increase by 300%. Very simple. the surface area would increase by 300%. So what about volume? You will say volume again is very simple, right? The volume would be x cube original, and then the final volume would be 8x cube, right? 2x cube. So it will become 2x cube or 8x cube divided by original was x cube into 100. Again very simple. If you simplify it, it would come out to be 700%. Very, very simple. So this was a very simple example which illustrates what these problems are all about. Now we will move to slightly more complicated example. Here again we are dealing with a volume problem, and in this case instead of having a square we have a cylinder, a right circular cylinder, right? So and then you have to be familiar with these formulas. We'll deal with the chapter on measurement and areas and volumes later on. We'll deal with all the problems, but you have to be familiar with these formulas. Here the formula for volume of a cube is volume of a right circular cylinder is pi r square h, right? So initially let's assume the radius to be 100 r. I can assume anything, whatever I want. This changes to 115 r because it is increased by 15%. Of course the height was reduced from 100 h to 80 h, right? Remember, I have kept the variables separate, r and h. If this was r, I could not have taken this to be r because nowhere in the problem it says that radius was equal to height. I cannot do that, right? That would have been a mistake. So this is what finally I plug into the formula. My final volume comes out to be into 80h. This is my final volume. My original volume is 100 r square. Of course there is a pi here into 100 h, and then of course everything is done with respect to the original, right? So this remains 100 pi into 100 r square into 100 h. Right? If you notice, all of these factors r square, h square, all of these would cancel out, and you will only be pi would also cancel out. You will only be left with numbers 115 into 8 and 100 square into 100 and so on and so forth. Of course this would be multiplied by 100. If you simplify this would come out to be 5.8%. So r and h would cancel out and you will be left with only 5.8%. So again very simple application of the formula. Remember, all percentage change is always with respect to the original quantity, right? If nothing else is specified in the problem. This is again, right, a slightly tricky problem, but of course if we read it very carefully, we can very easily solve it. It is not difficult at all, by no means it is difficult, only the language is slightly tricky. Krishna's salary is 20% less than Radha. So what we have here is there are two persons, Krishna and Radha. Let's assume Radha's salary to be 100x. What does it tell us? It tells us Krishna's salary is 20% less. So 20% less than Radha. So comparison is with respect to whose salary? Radha's salary. Therefore we have to convert Radha's salary to Krishna's salary, and we are saying that instead of 100x, Krishna only gets 80x. So that's one thing to be clear. Now what is the question asking? Question is asking by what percent Radha's salary is more than Krishna. So now in the question what we have to find out? We have to find out Radha's salary with respect to Krishna. So the calculation has to be done with respect to Krishna. So straight off the bat you would say that Krishna's salary would come in the denominator when I calculate percent change. Right, here it's percent difference of course, but it's again percent change is the same formula. So Krishna's salary comes here in the denominator, and of course by what percent more means that we have to calculate the difference. We have to take the difference of the salary at the top. So it's 100x minus 80x. It is always absolute. The difference is always absolute. So if you calculate it, this would come out to be 25%. Again, not very difficult, right? Just the language is little bit convoluted. Now this is a percentage conversion question, right? It's a percentage comparison question. So here what we have to do is we have to compare the value of two percentage calculations. Now there are two ways to go about solving this. Income is given, you can calculate 10% tax over 200, you can do that, right? So 10% tax over 200 would be 2000 minus 200 into 10%, you can calculate it. 12% tax over 400, similarly you can calculate 2000 minus 400 over, and this is of course 12%, and you can calculate that as well, and ultimately it's asking you what would be more, right? So you can do the calculation and do it. It's not very difficult. It would be simple only. Right? This would be 180 and this would come out to be 192. So it's not very difficult if you do it this way. But I want to illustrate a little bit of point here. What I don't want is, I don't want to get into such big calculations, right? These numbers I have chosen are simple, so even these big calculations don't turn out to be trivial, but the thing is, I don't even want to go here. Then what is the simpler way? What would be the simpler way? Just by understanding the language, can we come up with a simpler way to solve such problems? So first thing is, let's look at this 10% tax over 200, and the second case is 12% tax over 400. So here what I have to pay extra, right? Still 400, after 400 rupees, right? After I have earned 400 rupees, let's say I earn for income over 400 rupees, I have to pay 2% extra in this case. What is my income over 400 rupees? It's 2000 minus 400, which is equal to 1600. And if I calculate 2% of this comes out to be 32. So in this case, where is the extra tax coming from? It is coming from this 2%, difference of 2% over an income of 400, right? This is where in this case the extra tax is coming from. And what is this extra tax amounting to? This extra tax is amounting to 32 rupees, right? 32 rupees extra. And what about this case? Where is the extra tax in this case coming from? The extra tax in this case is coming from this difference. Here I am taxed at income above 200, here I am taxed at income above 400. So here I am being taxed early. There is a difference of 200 rupees between this, and this 200 is taxed at what rate in this case? 10%. It is taxed at 0% in this case. Therefore, because of this 10% on 200, which is equal to 20 rupees, there is an additional tax of 20 rupees in this case. So 20 rupees extra in this case. Here I have to pay 32 rupees extra, and there I have to pay 20 rupees extra. Therefore, in this case I have to pay how much more tax? 12 rupees. Again, same answer as last time, right? But the thing is, here we had to deal with only small numbers. Typically in this question, what I would like you to do, I would like you to straight away come up with this 22, 20 and 32. That's what I would like you to, right? After we have understood all of this, we can straight away write 20 extra in this case, 32 extra in the second case, and hence difference of 12 rupees. Very, very simple. Moving on, here we have a slightly confusing question. Here there is a person who is doing all the hard work and he is getting rupees 2400 at this rate. But the question, if you look at the question, what is it asking? It is asking percentage change in his income. It is not even asking absolute values, right? So what would most students here, as soon as they see this, oh 60 rupees, oh let me calculate here, they will start doing calculation right away. They will arrive at like big numbers, calculate 16% of what is 60 and so on and so forth, and they will waste lot of time. But look, read the question carefully. It is not asking anything. It is not asking absolute value of anything. So why do I have to worry about absolute value? This is all garbage. This is junk. They might have given you right 59 and some big numbers here, but this is all junk. You don't have to worry about this. What do you have to worry about? You have to only worry about percentage change. So let's assume previously that 100x is my per hour salary. So now it became what? 116x, and hours were 100y, and they are now reduced by 20%, so they became 80y. Previously what was my take home income? 100 into 100 xy, and now what is my take home income? It is 116 into 880 xy, that is equal to 9280 xy. Now all you have to do is you have to calculate percentage change. Percentage change is xy minus 9280 xy divided by, of course we have to worry about original value, we only have to worry about original value here. So that's what I would do, I am going to use original value. Original value was this one and into 100, and if you calculate this, this would come out to be 7.2%. Again, not very difficult, provided you don't get confused. Just read the question very carefully, understand the language, understand what it's asking, and you will be able to solve it very simply. Now here is another kind of question. These kind of questions are also asked. Here the question is changing the numerator and denominator of a fraction and asking us if the value of the fraction is given, the final value, what would have been the original value. Let's assume the fraction to be n by d, which essentially means that it could be 100n by 100d. Right? I want 100 factor of 100 here because I want to increase the numerator and decrease the denominator by certain percentage. So that's why I want a factor of 100 here. I really like it. Increased by 200%, which means it became what? 200n. Denominator is increased by 360%. Therefore, what did it become? 360d. Now it is telling me that this is equal to 5 by 12. So what would be my original fraction? I can calculate it from right here. If you simplify this, this would come out to be 4 by 3 into n by d is equal to 1, or n by d is equal to 3 by 4, which is your answer. Again, very simple, not difficult at all. Now this is a slightly again tricky problem, not because of computation, but because it's very hard to internalize. This is slightly tricky, not very hard, but slightly tricky to internalize what the problem is actually saying. Right? So for that, let's use an illustration here. Here what the problem is saying is that I increase the income tax on a certain income, certain gross income by 19%, and because of that my net income, the net income is what I am able to take home after tax is deducted, my net income reduced by 1%. Right? So this, it essentially means, if you think about it, right, the way to think about it is gross income. This is my gross income entirety made up of two parts, yellow and red. This is my net income and this is my tax. So if I deduct tax from my gross income, I am left with net income. This is what I take home. Now what happens, I am asking you, what would happen if I increase the tax by 100%? So previously only one block was tax, now two blocks are tax, so tax doubled, which means the tax increased by 100%. My net income, right, because gross income is same, I cannot increase number of blocks here. So if I added one block from here, I have to remove one block from here. My net income reduced by one of these blocks, yellow blocks, which is equal to what? 25% of the net income. So 100% increase in tax led to a reduction of 25% in the net income, but ultimately 25% reduction in net income is same, right? The size of this block, these two blocks essentially have to be the same size because gross income is same. Therefore, one of this red block is not equal to one of this yellow blocks. It means it has to be equal, in absolute value of this red block has to be equal to absolute value of this yellow block. It means that 100% income increase in tax is equal to 25% reduction in net income, right? So 100% increase in tax is same as 25% reduction in income. Right? So this is not the case that we took in, that is given in the problem. This is our own case, but essentially, right, the problem is based on your understanding of this concept. Right? So there in the problem, were to be increased by 19%. So 19% increase in tax, the absolute value of this thing has to be equal to the absolute value of 1% of the income. Right? Because these quantities have to be absolutely the same for the gross income to be kept constant. Right? This is what I want you to write as soon as you read the problem. This is the understanding, level of understanding that should be there just by reading the problem. This is what the formula that you should come up with. Of course, if you are having trouble here, right, if you are having trouble going directly here, then we can go. So 19% of tax is same as 1% of income. Right? This is where we want to come. Of course, we can come here using another understanding. So my gross income, let's assume that my tax is 100T and my income is 100I. In the first case, my gross income is 100T plus 100I. Correct only? In the second case, my tax was reduced, my tax was increased to 119T. Correct only? 19% increase, and my income came down from 100 to 99. It came down by 1%. Now these two quantities essentially have to be the same. Like I told you, the gross income, for the gross income, the number of blocks to remain constant. These two quantities have to be the same. Now if you simplify this 100I would come here, which will become I, 99I would come here, and then we would be left with only I. This 100T would go there, and we would be left with 19T. Essentially same thing as before. Right? This is the thing that you should be able to arrive at as soon as you read this problem. Now once we have this understanding, we can calculate the tax. Gross income is made up of I and 19T. Therefore my total income is I plus 19T. Sorry, T plus 19T. Right. T, I plus T, and of course I is nothing but 19T. So my gross income, my total income is T plus 19T. What is the tax? Tax is only T, and if I calculate percentage of this, T divided by, this is the tax, divided by gross income, this is the total income, I plus T, I is 19T. So T plus I is 19T, so 19T comes here into 100, this is the percentage tax, and this comes out to be, if you calculate it, it comes out to be 5%. Again, very simple, provided that you understand the basic concept. If you read the language of the problem carefully, you would be able to arrive at this. Now moving on, again we are dealing with another problem in which we can use shortcut trick. We don't really have to solve all the percentages, everything, right? I mean, you are very welcome to do that, but you will end up wasting a lot of time. In this case, what we are given? We are given there is a village whose total population is 9,600, and it is made up of certain number of females and certain number of males. We don't really know how much, but I just assume them to be 100M and 100F. The males and females were increased by 8% and 5%. So instead of increasing them by their respective numbers, what I would do is I would increase everything by 5%. I will take the lower of these, which is 5%, and increase everything by 5%. So this 9600 becomes 5% increase, means it will increase by 5% increase, means it will increase by 480, right, which is basically 5 divided by 100 into 9600, and this comes out to be 480, and if you add 480 to this, it is increasing by 5%, so we have to add 480 to this, and this would come out to be 10,080. In this 10,080, what is the number of males? Males increased by 5%. Obviously, I am increasing everything by 5%. So this 100M becomes 105M. This 100F becomes 105F. Correct only, right? But in the problem, what are we given? We are given that this is not really the case. What has happened in the problem is, instead of increasing everything by 5%, the number of females were increased by 5%, but number of males were increased by how much? 8%. So if I increase number of males by 8% and number of females by 5%, the total population comes out to be 10,272. If I take a difference of these two, this difference is 192, and this 192 difference is coming from where? Of course, number of females are constant here and here, so it has to come from the number of males. So if I subtract 105 from 108, I get 3m. So this difference is coming from 3m, or m comes out to be 64. Therefore, number of males is 100m, which is equal to 6400. Again, very simple, no calculations. Just keep this basic concept, the language of the problem in your mind, just understand it and arrive at these relations very quickly, and you will be able to solve these problems in a jiffy, very easily. Now again, moving on, again a similar problem, but slightly tricky. Here, what are we going to draw? We are going to draw the population to be 8,000. Male population is increased by 10%, female population increased by 8%. What is the lesser of two? 8%. So we are going to increase everything by 8%. But instead of writing the final figures here, I am not going to write the final figures here. I am just going to write the increase. Just going to write the increase now. So I am increasing everything by 8%. So if I increase everything by 8%, 8 8 is 64. So this population would increase by 640. So this is just an increase. I am writing the increase here. And this increase of 840, if I assume this to be 100m and 100f, this 100m would increase by to what? 108m. It's an increase of 8m. And here there would be an increase of 8f, right? Similarly, this is 8f and this is 8m. This is the 6400. But of course, what I am being told is that this really didn't happen. What instead happened was the increase was 9%. So increase was not really 8%, but the increase was 9%. So this increase was 720, and in this 720 increase, right, 9% of 8,000 is equal to 9 8s are 72, 720, and this increase of 720 came by because of females were of course increased by 8%. So 8f and 8f remains constant, but the males, instead of being increased by 8%, they were increased by 10%. So 100m became 110m, which is an increase of 10m. So now this difference between 640 and 720 minus 640 is coming from where? Number of females is same, the increase in number of females is same here and here, but the increase in number of males is different. Therefore, this difference must be coming from the difference in number of males, and of course this comes out to be, if you solve it, this would come out, m would come out to be 40, and if you plug in 40 here, you would get 4,000. So number of males and females were equal and they were 4,000 each. Again, very simple, right? Same as last problem, we solve it in a similar way, but instead of writing absolute values, I could have very well done it with absolute values, but just to illustrate, I wrote only increases here, and we are dealing only with increases here. You can do it any way you like. Now this would be our last problem, and again in this case I would appeal to your sense of imagination here, and of course if you have listened to our last class, you should definitely listen to through the last class if you haven't done that already. But just by using your imagination, you can think about, there are two scales involved here. In this problem, there are two scales, which is typically the case in all kinds of percentage, ratios, all those problems. One is the relative scale. This is our relative scale. It is the percentage scale. Here, the marks are varying from 0 to 100x. And this is our absolute scale, this side. On this thing we have our absolute marks, and somewhere here is our line of passing, right. So here is our absolute, this is our relative scale, and here we have absolute marks. Okay. The problem is giving us data sometimes here, sometimes there, and that is why this confusion is arising. Many people find it difficult to translate from here to here, but we have a factor of x here. This factor of x, right, when is used to, if we find the value of this x, we can go easily from here to here, because the x is just a multiple anything here when multiplied by x would take us to the absolute value. We understand that. Now how to go about solving this? A student scores 30% marks, then he fails by 5 marks. What is 30% of 100x? We already know that it's 30x, and of course the 30x would map to somewhere here. We don't really have to worry about where it maps right now, but we understand that it would map somewhere here. If he scores 40% more marks, right, and it is failing by, on the absolute scale, 30x translates to a number here, and this number is such that he is failing by 5 marks. So he is 5 marks less than the passing marks in the absolute scale. Similarly, if he were to score 40x, then he passes by 10 marks, which means that he is 10 marks above the passing marks on the absolute scale, on the absolute value scale, on this line. Now, of course, we don't know these values, so we cannot do anything about that, but we do know these values. So what if I calculate the difference between here and here? The difference is 30x minus 10x, which is 30x minus 40x, which is 10x. 10x is the difference here. 10x of difference here translates to 15 marks here, right? In this way, we know that x is 1.5, and thus, my friend, the scale, the multiplying factor that we have to use when going from here to there. Very, very simple. So with that, can we 1.5 is the multiplication factor. So what is the total marks? What is the total marks? It's 100x, which means 100 into 1.5 or 1500. Very, very simple. What is it asking next? Find maximum marks. What about passing percentage? Can we find out the passing percentage? It's not asking the passing marks. This 30x translate into absolute scale. We can do that. It comes out to be 45, right? 30 multiplied by 1.5 is 45. 30x on the relative scale, on the percentage scale, translates to 45 absolute marks. Of course, this 45 is 5 less than the passing marks. Therefore, passing marks must be 45 plus 5, 45 plus 5 or 50. Therefore, percentage passing must be what? Either you can calculate it by doing 50 divided by 1500 into 100. You can do that, that's also very fine. But we can do it another way also. The way we can do it is, can we translate 50 and take it from here to here? Yes, we can. Anytime we have to come to this side. In this cases, we are going from here to here, multiply by 1.5. To come here from the absolute scale to the percentage scale, what do? We divide by 1.5 or divide by 1.5, and we come to this side. So this 45 plus 5 is 50. 50 when translate, if you want to convert it into percentage, we divide it by 1.5. So this is our passing percentage, and if you solve it, it would come out to be 33.3%. Again, very, very simple, not difficult at all. With this, we end our lecture. Today we learned a lot of shortcut tricks. I mean, all the questions that we solved today actually were using shortcut tricks. So keep those in your mind, right? And the key here, the key in all the questions, the uniform thing in all the questions was reading the language carefully, first of all. Second, understanding what is being asked, absolute quantities or relative quantities. If the quantities, if the final answer only wants relative values, then assume whatever you want, whatever the hell you want, just to make the calculations simple. Right? Those were the only two things involved in all the problems today. In the next class, we will continue our solving problems, more problems on percentages. Next class we will deal with problems related to expenditure. If the expenditure is decreased by this much amount, the price of rice increases, price of sugar increases by this much percentage, right? All of those things, right? What has to be the percentage change so that consumption is kept constant or consumption changes by this much, that much. All of those problems we will deal with in the next class. In the next class we will also deal with problems related to commissions, bonus, right? Salesman gave commission to the company, this is the bonus he gets, what is the percentage? All of those kind of problems we will deal with in the next class. Again, very important, next class is very important. So I request you to do subscribe to our channel. That is the way we can easily communicate, and do enable the notification when you do the subscription. Thank you very much. Have a good day.